Hey everyone, welcome back. Today we get to learn about transforming polynomial functions. Yay! Okay, by the end of today's lesson, you're going to be able to transform polynomial functions. You can perform the same transformations on polynomial functions that you performed on quadratic and linear functions. Let's talk for just a minute. If you had the equation y equals x to the third plus 4, that can also be written as a function. Let's say f of x is equal to x to the third plus 4. And in these two, f of x and y mean the same thing. They're both talking about what's happening in the vertical on our x and y coordinate plane. Okay, so if we're talking about the y or the f of x, we're talking about what's happening in the vertical. All right, and the x, remember, is talking about what's happening in the horizontal. What's happening in the horizontal? So let me pull up a chart for you. This is a chart of transformations of f of x, of the function f of x. So remember, f of x is the same thing telling us about our y. All right, so if we're doing a vertical translation, we're going to take our y and just move it up or down, as the case may be. So all we have to do is say, if we're doing a vertical translation, we take what's in the y, our vertical, and add or subtract from it, and we'll have a vertical translation. For a horizontal translation, remember, horizontal is telling us about the x. So when something is snuggled up inside the parentheses with our x, we know that it's going to be a horizontal translation. And remember, horizontal is horrible. We kind of think if it says x minus 2 that we're going to end up going 2 units left, but actually we're going 2 units right. And when we see x plus 1, we're not going to the right, we're actually going to the left. All right, let's talk about a vertical stretch and compression. Again, vertical is dealing with our y, which is the same as our f of x. Let's always remember that. Y is the same as f of x, and y deals with the vertical. So here, we're just multiplying by our y, and that's going to give us a vertical. Now, let's remember, for the stretch and compression, if this number, this coefficient, is greater than greater than 1, then we call it a stretch, all right? If it's less than 1, like a fraction, then we call it a compression. All right, so that's how we know whether it's a stretch or compression. So now let's talk about the horizontal stretch or compression. Remember, horizontal is dealing with our x, and our x, if it's snuggled up inside the parentheses with our x, that tells us it's going to be a horizontal stretch or compression. Again, horizontal is horrible, and so if I have a problem like this, g of x is equal to 1/5 x to the third power. To tell whether it's a stretch or compression, we have to actually go back to this 1 over b. So 1 over 1/5, all right? And this means divide. And so in order to divide, I'm going to multiply the bottom by 5 over 1 and the top by 5 over 1. That leaves me with 1 in the bottom, and 1 times 5 equals 5. 5 is greater than 1, and so that tells me that this is a stretch by a factor of 5. All right? In this case, I'm going to, again, look at this 3, and I'm going to say, okay, 3, but it has to be 1 over 3. 1 over 3 is less than 1 whole, and so this tells me that this is going to be a horizontal compression by a factor of 1/3. All right, and finally the reflection. Let's talk about what the reflection means. If it says reflect across the x-axis, let's look over here at our x and y coordinate. If I have a point, say right here, and it reflects across the x-axis, so it reflects across the x-axis. Notice that the x component stays the exact same. Let's say this was 2. It stays in the 2 position on the x, but my y is changing from positive y to a negative y, or negative to positive. So when you're reflecting across the x-axis, you're actually changing your y. Your y is going to be the opposite of what it was before. So we're going to say that we're going to take the opposite of f of x, which is what we do right here if we're reflecting across the x-axis. If we're going to reflect across the y-axis, let's use this point again. Let's say we're right here. We're at x is 2 and y is 2. Let's say that. And this time we're going to reflect across the y-axis. So notice this time my y stayed the exact same, but this time my x is exactly opposite. So in order to get our x to look exactly opposite, we're going to have our f of x, and we have to snuggle inside that parentheses with our x to show that it's a reflection across the y-axis. Okay, so that means our x is going to change from positive to negative. All right, so you may need to refer back to this chart, and you can also find it in your textbook on page 460. All right, so before we get further into this, let's just talk about the parent function of x to the x cubed. All right, let's take a look at what that parent function is. Remember, the parent function of a graph is the most simplest form of the graph, and so this is the most simple form of a graph. So when we're looking at f of x equals x cubed, the first thing we want to do is go ahead and set up a table, an x and y chart, and let's just fill it in. So when x is 0, y is 0. All right, so we'll just put that plot on there, 0, 0. When x is 1, 1 times 1 times 1 is 1, so our y is 1. So let's plot that one. There it is. All right, when x is 2, 2 times 2 is 4, times 2 is 8. So there, now we need to plot our 2, 8, and there's that one. Let's go with negative 1. Negative 1 times negative 1 is positive 1, but we have to multiply it one more time by negative, so it ends up being a negative 1. So our next point is negative 1, negative 1. Let's try negative 2. Negative 2 times negative 2 is positive 2, times one more negative makes us a negative 8. So let's plot that point. All right, so now that we have our points plotted, we can go ahead and draw our graph, and it looks like that. And so that is our parent function of x to the third. X cubed looks like this. This is what x cubed will look like. And we'll just label that graph F. All right, so here's a simple review problem. It says graph the function. So the first thing we want to do is take a look at this, and we can see that there is an x to the third power. So we see that that's going to be our parent function. So let's graph our parent function first, and we just did that. So here's our parent function. Let's label that P. All right, so now it just says take our parent function, and it says minus 6. Now notice that what we can say is when x is 0, y is negative 6. Okay, so what we're doing is we're actually going to be translating our function. It's going to be a vertical translation by negative 6. So here, let's just make a chart and take a look at it. Here's our x and y. So when x is 0, y is negative 6. And so we want to plot that, and there's that point. When x is 1, y is negative 5. Sorry, I got my plots all mixed up here. So there's 1 and negative 5. When x is 2, y is 2. That's already there. When x is negative 1, y is negative 7. And we plot that point. And then when x is negative 2 times negative 2 times negative 2 is actually negative 8, plus a negative 6 is negative 14. So there it is. So now we can sketch our graph in and take a look at it, and you can see, we'll go ahead and that it is just the exact same as our parent function, but it's a vertical translation 6 units down. And so we'll label our new graph F, and our parent function was P. Let's try this example here. So the question says that we're going to take f of x equals x to the third minus 6, and then we're going to write the rule for each function and sketch the graph. So let's see what we're going to have to do. So first of all, let's just try and figure out what f of x is equal to x to the third minus 6 is going to look like. So I see that it's going to be our parent function minus 6. So here's our parent function, and we're going to call that P. And now we're going to take our parent function and minus 6. So I'm just going to move it down by 6. All right, I hope you can see that. So there's my f of x. Now let's take a look at what the rules tells us to do. This says to take, and we're going to make a new graph, and we're going to call it G. And g is going to be f of x minus 2. So we're going to say, well, what is f of x? Well, f of x is actually, right here, it tells us f of x equals x to the third minus 6. So in place of f of x, I'm going to put x to the third minus 6. Okay? So let's go ahead and do that. So there it is. In place of f of x, I just put x to the third minus 6. And now I can see minus 6 and minus 2 is going to be a minus 8. All right, so let's take a look at this. Let's go back and look up here. It says f of x minus 2. So I see the red, f of x, and I'm going to just minus 2. All right, so we end up with f of x, and we just moved it down 2. All right, and if we actually work out our problem over here, we can see x to the third minus 8. So when x is 0, y is negative 8, which is exactly what we have down here. So what that tells us is to graph f of x, g of x equals f of x minus 2, we're going to translate the graph of f of x 2 units down. And this is a vertical translation, and that's exactly what we did. We just took the f of x, which we saw was x, this red one, and we just moved it down 2 places, 2 units. All right, let's try another one. Okay, take a look at this next problem. It's the same kind of thing. We're going to start out with f of x equals x cubed minus 6. So let's go ahead and get that taken care of first. So first we're going to write our parent function. Here's our parent function. And it says to take the parent function minus 6. And this is 6 is actually going to be a vertical translation of minus 6 down to negative 6. So we're going to take a new x cubed and subtract 6. There we go. Okay, so here's our f graph. And we're supposed to take our f, and we're going to make a new graph, and we're going to call it h. And what we're going to do is say h is going to be f of x plus 3. Now, notice that x plus 3 is snuggled up together with our x. Okay, so that tells me this is going to be a horizontal translation. And it's going to be, remember, horizontal is horrible. So instead of it going 3 places to the right, my graph is actually going to be going 3 places to the left. Okay, because we want to make that end up being 0. So negative 3 plus 3 would be 0. Okay, so another thing is whenever we have a function like this, and we say solve for f of x plus 3, we take what's inside the x plus 3 and put it anywhere we see an x in our f function. So here I see x to the third, so I would want to go ahead and fill in the x plus 3 in place of the x. Okay, so now that tells me that my x is going to be translated 3 units to the left. So here's my f, and it's going to be translated 3 units to the left. All right, so let's let it go. It's going to be a horizontal translation, 3 units to the left. There it goes. And that's all you have to do. And we label it H. All right, try this one on your own. Turn the video off and give it a try. Okay, so this problem says to take the function f of x equals x cubed plus 4, and then we're going to write the rule for the function and sketch it for the new function, which is going to be g of x. So the first thing you want to do is figure out what f of x is going to look like. So let's take the parent function, f of x equals, or p of x equals x cubed. So there's our parent function. And this time it says plus 4, so it's going to move up 4 because that's a vertical translation. So there's our parent function. We've made the parent function, and now let's make it go up 4. There we go. So there is f of x, and we'll just call that graph f. Okay, now it says to take the new, we're going to make a new graph, and we're going to call it g. And in g is going to be f of x minus 5. So g is going to take f of x. Now, what is f of x? Well, we can just substitute because it told us f of x was x cubed plus 4. Okay, so we're going to take f of x, and we're going to now say x cubed plus 4 minus 5. So we're going to take our f and just bring it down 5 units. Okay, And so there we have it. So let's go ahead and do the math part of it also. Let's label that G. All right, so let's take a look. When I substitute in place of f of x, if I substitute our x to the third plus 4, and now I add my like terms together, I end up with x cubed minus 1. And let's just check our G graph. So our G graph, when x is 0, y is negative 1. And sure enough, when x is 0, y is negative 1. And that's exactly where our graph landed. So what we had, to graph it, to graph g of x equals f of x minus 5, we translated the graph f of x 5 units down. And this is called a vertical translation. Okay, try one more on your own. Turn the video off and give it a try. All right, so again, same rules. We're going to start out, we need to graph our f of x equals x cubed plus 4. So in order to do that one, we're just going to come up with our parent function again. And again, this is going to be a vertical translation 4 units up. So we'll take our parent function and move it up 4 spaces, 4 units. All right, so now our new graph that we're supposed to make is going to say take f, and we're going to substitute x plus 2 every time we see an x. And we can remember that whenever there's something snuggled up in parentheses with our x, that tells us it's going to be a horizontal. Horizontal is horrible, so we're going to take f and we're going to move it 2 places to the left. Okay, so we need to just fill in this equation right here. In every place we see x, we're going to put in x plus 2. And so there that is. Now you don't have to multiply it out, but you can. And so there it is. Really, as long as we understand the rules here, this time we're just going to take our f and we're going to have a horizontal translation to the left by 2. Okay, so we're going to translate 2 units to the left. So we're going to take my f and just move it 2 places over. There it is. And here is our rule. G of x is equal to f of x plus 2. And that's what it does. It's a horizontal translation. And we'll name it. Okay, so let's look at this example. This is a new problem. It says reflect the polynomial function. So this time we're going to reflect f of x across the x-axis. So let's just remember what that means. So when we have our x and our y, if we have a point here and I need to reflect it across the x-axis, that means it's going to go down like this. So our x's are going to stay the same and the y is going to be opposite, okay? So what that means is we're going to take the opposite of y. Now remember, f of x is the same as y, so if I'm taking the opposite of y, I'm going to take the opposite of x, of f of x, sorry. So my new function is going to be g of x is the opposite of f of x. So that's going to be my new graph is going to be the opposite of my y. So what I have to do now is, what is f of x? Well, f of x is this whole thing here. So let's just write it out. So here we have the negative of my f of x, opposite of my f of x. That's going to give us a reflection across the x-axis. Now, we're not quite finished yet because this is actually a negative 1. And so I need to distribute my negative 1 to everything here. All right, and so here it is. Everything's been distributed, so all of the signs have been changed. So when you put it into your calculator, you're going to need to graph both of these pieces. And let's just review a little bit about our end behavior and see if we can kind of guess at what this is going to look like. We see that this is a cube root, and this number is greater than 1 or equal to 1. So what that tells us is that our end behavior is going to start from the bottom and go to the top. Okay, it's going to go like this. So let's take a look at our graph. And here's what you see when you put them both in. When we just put 1 in, we start from the bottom and go to and end up with this behavior, okay? And now let's look at what's going to happen here. Here I still have a cube, but now I have a number less than 1, so that means I'm going to go the other way. I'm going to start from the bottom that way and go up, which is exactly what happens over here. So That way you can kind of start to remember your end behaviors also. All right, let's look at another example. In this example, it says we're going to reflect across the y-axis. So again, let's take a look at what's going to happen. This is my x, this is my y. I have a point here. I'm going to reflect across the y. So it's going to reflect across this way. This time my x's are opposite, but my y stays the same. Okay, so this time my x is going to be opposite. So let's look and see what that's going to look like. So notice that I'm going to just put my negative sign snuggled in with my x, okay? So that's how I'm going to get my x's opposite, but my y is going to stay the same. Okay, so what I have to do is everywhere where I see an x, I'm going to have to put negative x instead. So here I see an x, so I'm going to change it to negative x. Next I see an x here, so I have to change that to a negative x, and so on. Everywhere has to get changed. Whatever I see in here has to be replaced with each of my x's in my original function. So now that I have that written out, I can actually combine everything together and get it written out. And let's take a look at what the graph is going to look like. Again, let's take a look at what we have in our original function. We have an odd and a number greater than 1 or equal to 1. So I can see that my first one's going to go from bottom to top. Okay, so let's take a look. And there it is. And then my second one, again, I have an odd exponent, and this time my number is less than 1. And so this time I'm going to go from the, I'm going to have it just going the other direction. Okay, so you can kind of see what that looks like. It's a reflection across the y-axis. Okay, try this one on your own. Turn the video off and give it a try. All right, so the first thing we want to do is go ahead and take a look at what it means to reflect across the x-axis. So let's just take a look at that real quick. Here's our x, here's our y. We have a point. We're going to reflect across the x-axis. So that means it's going to be doing this. So that means our y's are changing, going to be the opposite of our y. So we're going to have opposite f of x, okay, which is opposite y. So let's take a look at that. So g of x is going to be opposite f of x. And so when we write that out, here's our f of x. Notice it's the exact same as what it was here. But we have to take the opposite. So don't forget, we have to distribute that negative to everything. Okay, not just the first one, but all of them. And that's going to be important for you to remember because it's going to be on your SAT test also. Okay, so once we distribute everything and get it down, then we can go ahead and graph it. Again, let's look at the first one. Notice that it's a cube again, so it's going to start from the bottom and go up. This is positive, so it's going to start up like this. So let's go ahead and see what the first one looks like. The first one's going to go like this. And then when we reflect it across the x-axis, notice that, again, we have a 3, so it's the same thing, but it's opposite. So we're going to go from the other direction. All right. All right, try one more of these on your own. Turn the video off and give it a try. Okay, I hope you're starting to figure these out pretty well. The question says to reflect across the y-axis. So let's just review what that is going to look like. We have an x and a y. If I have a point here and I'm reflecting across the y, that means my x is staying this. My x is actually going to be opposite, but my y stays the same this time. So my x is going to be the opposite. So this time we're going to snuggle up that minus with our x. Okay, and so now everywhere I see an x in my original equation, I have to change it out for negative x. Okay, so my g of x is going to equal f of negative x. So everywhere I see a regular x, I'm going to have to replace it with negative x. And once I do that and multiply it all out, there's what you get. And so next you want to put it in your graph. And let's just take a look at what happened on this. The first one started out and we reflected our first graph this way, and then the second graph reflects across the y. So there you have it. Okay, so now we're going to start working on compressing and stretching polynomial functions. So the problem says let f of x equals 2x to the fourth minus 6x squared plus 1, and we're supposed to graph f and g on the same coordinate plane. And then we have to describe g as a transformation of f. So let's just start out, and the thing that I like to have is our handy little chart here. Okay, so let's see if we can figure out what is going to happen here. So it says that g of x is going to be 1/2 times f of x, which, remember, f of x is called a y. Okay, so we're going to be doing something vertically, and we have to look at this 1/2. So let's look at a vertical stretch or compression. Now we have to decide, is it a stretch or compression? Well, it's 1/2, which is less than 1. And so we can see that this is going to be a vertical compression. All right, so we already know what's going to happen. It's going to be a vertical compression by a factor of 1/2. So there it is. It's a vertical compression of f of x. Well, let's go ahead and solve this. This says to take 1/2 and multiply it by what's in f of x. So here's f of x. So we're just going to multiply 1/2 by f of x. So now I have to distribute my 1/2 to everything. And when I do, I get this equation. And when you put it in your calculator, you're going to see it looks something like this. So you're going to see a compression of the original f of x. So when the blue is the f, and then it gets compressed in, to the g. Okay, let's look at another. All right, so this one's a little bit different. Again, we're going to, this time, take a look at what's happening here. All right, so we can see that we're going to be dealing with the horizontal part this time, because notice this is snuggled up with my x. Okay, but remember, horizontal is horrible, so we have to take whatever this is and put it over 1 over it. So we're actually going to say 1 over 1/3. Okay, and when we actually divide that out, if you multiply 3 over 1 times the top and 3 over 1 times the bottom, 3 over 1 on the top, 3 over 1 on the bottom. Our 3's cancel out. 1 times 3 is 3, so it's 3. So we can see that we're going to have a horizontal stretch by a factor of 3. In this case, it's 3 up here. Okay, so just by looking at that. Now let's actually do this. Now remember, let me go ahead and let's make that statement. It's a horizontal stretch. Okay, so now remember, whatever's in here, we have to fill that into every single x. 1/3 x. In place of x, we're going to put 1/3 x. Okay, so here it is. See, we put 1/3 x in place of every x. All right, and there's your actual equation. And once you work it all out, it's kind of long, but when you put it in your calculator, you can see what's happened. F was kind of skinny, and then it stretched out a little bit to be G. All right, you ready to try one on your own? Give it a try. Turn your video off and give it a try. Okay, so the first thing we want to look at is what happened here, and looks like I've got something multiplying by y. So it's going to be vertical. This number 1/4, let's take a look at our chart. 1/4 is less than 1. And remember, compression, if it's less than 1, it's a compression. Less than, compress, okay? So we actually have a vertical compression by a factor of 1/4. So it's a vertical compression. Now we have to look at what we're going to do. So it says take 1/4 and multiply it by f of x. Well, what is f of x? Well, in place of f of x, I can put this whole equation there. So I'm going to multiply 1/4 times that equation. Now I just have to distribute my 1/4 to everything. And when I do that, end up getting this equation here. And you can put it in your calculator. And you will see that g of x is a vertical compression of f of x. All right, try one more on your own. All right, try one more on your own. Turn your video off and give it a try. Okay, so let's take a look at what happens here. We notice that 1/2 x is snuggled up with my x here. Okay, so that means we're going to have a horizontal change, and we have to decide, remember, horizontal is horrible, so we're going to have to decide whether it's a stretch or compression. So let's take a look. It's actually going to be 1 over 1/2. So to solve 1 divided by 1/2, I just do it this way. You could do it in your calculator or whatever, but I multiply the bottom times 2 over 1 and the top times 2 over 1, so I end up with 2. 2 is more than 1, and so that tells me that I'm going to have a horizontal stretch by a factor of 2. Okay, so I'm going to have a horizontal stretch. Now, how do I write the new equation out? Well, every place I see x in my original equation, I'm going to replace it with 1/2 x. So I'm going to put a 1/2 x there and a 1/2 x there. And so there you can see it. I just filled in, and then you have to multiply all that out, and you end up with x to the 4th minus 3x squared plus 4. So let's take a look at the graph of that. When you put it in your calculator, you can see that g is stretched out a little bit from the original function of f. All right, so now we're going to start combining transformations. In this problem, we're going to take a function and transform the function f of x equals 6x cubed minus 3. And what we're going to do is we're going to compress vertically by a factor of 1/3 and shift 2 units to the right. So we're going to have to make a new function, a new graph, and we're going to call it g. So let's see if we can figure out what it's going to look like. So we have to compress vertically. So to compress vertically, we're going to multiply 1/3 by y. Okay, our f of x. So here's our 1/3. Now it says to shift 2 units right. So that's a horizontal movement. And it says 2 units right. And remember, horizontal is horrible. So instead of writing 2x plus 2, we have to say x minus 2. Okay, so I'm going to clean this up just a little bit. And so let's see if what to do with this. So first of all, notice that we have to take x minus 2. So everywhere we see an x over here, we're going to replace it with x minus 2. All right? And then we're going to also put a 1/3, and we're going to have to distribute our 1/3. So let's rewrite it. So notice everywhere I had an x, I replaced it with an x minus 2. And then I'm going to multiply by 1/3. So then I'll distribute that to everything. All right? So when I do all the math, I end up with this equation. And you can graph it, and here's what the graph would look like. So we take our original function, we're going to actually compress it by 1/3 and then move it over to the right, 2 units. Let's try another one. In this one, we're going to do the same thing. This time we're going to reflect across the y-axis and shift 2 units down. So let's remember what a shift across the y-axis is going to look like. If I have a point here, I shift across the y. That means I'm going this way. So that means I'm going to take my f and I'm going to replace it with negative x in there. Okay, so everywhere I see an x, I'm going to replace it with negative x. I'm also going to shift 2 units down. Okay, that's a vertical shift down, so we're just going to have to put minus 2 at the very end of our equation. So here's our minus 2, and here's our f of negative x. So what we're going to do is replace every x with every x up here, and we just have 1, with a negative x, and then minus 2 for our shifting down. So here it is. I replaced it. It was originally just x, and I replaced it with a negative x. All right, and then once you multiply that out, you end up with g of x equals negative 6x to the 3rd minus 5. Put both of these into your calculator, and you'll see two wonky graphs like that. All right. Okay, so why don't you try this one on your own? Go ahead and see if you can get this done, and see if you can get it into your calculator and match it up. Turn the video off and give it a try. All right, so in this one, it says that we're going to compress vertically by a factor of 1/2. So that tells us that we're going to take f of x, and we're going to compress it, so we're going to put a 1/2. All right, and then we're going to move the intercept 3 units to the right. So that's horizontal, and we're going to the right. So remember, that's going to have to be a minus 3. So here's what we have. 1/2 is a compressing of our y. And then notice I need to move 3 units to the right, so that's horizontal, so it's snuggled up with my x, and it's going to the right, so I have to say minus 3. All right, so that's all the main thing you need to know. So we're going to take everywhere we see an x, we're going to put an x minus 3. So this is going to change to x minus 3, and then we're going to have a 1/2 that we'll have to distribute to all of that in the end. And so here we go, and there it is. And let's take a look at what the graph would look like. There it is. So hopefully you saw something like that on your calculator. Okay, one last problem, and I'm not going to have you turn your video off because this one is really long and complicated, so we're just going to fly through it real quick. So what this problem is asking us to do is reflect across the x-axis. So let's just draw a picture so we remember what that looks like. Okay, if we're going to reflect across the x-axis, then we're going to change our y's. So we're going to say the opposite of f of x. Remember, f of x is the same as y, so our y's are going to be changing. All right, and then we're going to move 4 units left. That's a horizontal movement, and horizontal is horrible. So instead of saying x minus 4, we're actually going to say x plus 4. So let's take a look at what the rule is of our new function. G of x is going to be the opposite of f of x, and notice that our 4 is all snuggled up inside here with my x, so that tells us it's horizontal. And now what I'm going to do is every place I see an x up here in my original equation, I'm going to fill it in with x plus 4. And then I'm going to multiply that whole thing by -1. So let's take a look at that. There it is. And this is why I didn't make you work it out, because this would be x plus 4 cubed. Then you have to multiply all that by 6 and then subtract by 3. And so you can see it gets pretty long. But when you put it in your calculator, you should have gotten something like that. So there you have it. I know how sad you are that this video is over. I'll see you next time. Bye.